Chapter 2. Targeting the DOM, a complete guide to selectors. Welcome to Chapter 2. Now that you know how to get CSS into the browser, the next essential skill is aiming it. Selectors are the targeting system of CSS. They let you say exactly which elements should receive which styles. In this chapter, you'll master every fundamental selector: type, class, ID, attribute, and the combinators that let you navigate the DOM tree. You'll learn how to group rules efficiently, avoid specificity traps, and build a solid selector strategy that scales. By the end, you'll be able to point your styles with total confidence. Section 2.1: How Selectors Work. At its heart, a selector is a query. It's a pattern you write that asks the browser a simple question: which elements in the DOM match this description? When you write the selector h1, you're asking for every heading level 1 element. When you write .card, you're asking for every element with the class card. The browser takes your selector, scans the entire document object model, and returns a live list of all matching elements. Then it applies the declarations inside the rules curly braces to every single match. This is the fundamental loop of CSS. Select, then style. Understanding how that selection works, how precise or how broad it can be, is what gives you control over the visual outcome of the page. Selectors are not random strings. They follow the structure of your HTML. The DOM is a tree, and every selector is a set of directions for navigating that tree. A space between two selectors means any descendant, at any depth. A greater than sign means only direct children. A plus sign means the very next sibling. These symbols, called combinators, allow you to express relationships. You're not just saying style paragraphs. You're saying style paragraphs that are inside an article, or style a paragraph that directly follows a heading. The shape of your HTML informs the shape of your selectors and vice versa. Writing good selectors means thinking in terms of the DOM tree. The quality of your selectors directly determines the quality of your entire style sheet. Overly specific selectors lead to specificity wars, where you constantly write even more specific overrides just to change a color. Deeply nested selectors make your CSS fragile. A small HTML change can break the styling. And ID selectors, like #main, while powerful, can create isolated style islands that are impossible to reuse. The best selectors are the least specific ones that still reliably target the right elements. Usually, that means a single class. This chapter will teach you every selector type and combinator available, but the real skill is knowing when to use each one, and when to keep it simple. In this section, we've laid the conceptual foundation. Selectors are queries that target the live DOM, they follow the structure of your HTML, and writing them well is essential for maintainable style sheets. Now we're ready to meet the selectors themselves. In the next section, we start with the simplest and most common: type selectors, class selectors, and ID selectors. You'll learn the syntax, the specificity, and the practical rules for choosing between them. Section 2.2: The simplest selectors: elements, classes, and IDs. We begin with the type selector. A type selector is just the name of an HTML element. You use it when you want to style every element of that kind on the page. Let's say you want all your H1 headings to be dark blue. You would write the element name H1, then inside curly braces you write color: dark blue semicolon. The browser sees that, finds every H1 element, and makes the text dark blue. If you also want all H2 headings to be gray and have a thin light gray underline, you write H2, then inside curly braces color: gray semicolon, and then border -bottom: 2 pixels solid light gray semicolon. You can even style every button on the page. You write button, then inside curly braces background: blue semicolon, color: white semicolon, border: none semicolon. Type selectors hit every single element of that type. They are perfect for site-wide defaults. Now, what if you only want to style a few paragraphs, not all of them? That's where class selectors come in. A class selector lets you pick exactly which elements get the style. To use a class, you first give an element a class name in your HTML. You do that by adding class equals double quote and then the name you want, followed by double quote, inside the opening tag. For example, you could write pclass equals double quote intro double quote to mark a paragraph as an introduction. Then in your CSS, you target that class by writing a dot, then the class name. So .intro selects the element with class intro. Inside curly braces, you write the styles you want. For example, font-weight : bold semicolon, color : gray semicolon. Now only that paragraph becomes bold and gray. Every other paragraph stays normal. The dot tells the browser look for any element that has this class. You can reuse the same class on many elements across your entire website. An element can have more than one class. You separate the class names with spaces inside the double quotes. For instance, class equals double quote card featured compact double quote gives an element 3 classes: card, featured, and compact. The element will get the styles from all 3 class rules if you write them in your CSS. Let's build that. First, .card inside curly braces border : 1 pixel solid gray semicolon, background : white semicolon. That gives every card a gray border and a white background. Second, .featured inside curly braces border - color : orange semicolon. That turns the border orange for featured cards. Third, .compact inside curly braces font - size : 14 pixels semicolon. That makes the text smaller in compact cards. An element with all 3 classes gets a white card, an orange border, and smaller text. You can also create a rule that only applies when an element has 2 specific classes together. You do this by chaining the class selectors without a space. .card.featured. For example, .card.featured inside curly braces background : light yellow semicolon gives a light yellow background only to elements that have both card and featured classes. This is how you build component variants without ever needing an ID. Now let's talk about the ID selector. An ID is a unique identifier for a single element on a page. In HTML, you add an ID by writing ID equals double quote the name double quote inside the opening tag. For example, section ID equals double quote hero double quote creates a hero section with that ID. In CSS, you target an ID with a hash symbol. So #hero selects the element with ID hero. Inside curly braces, you can write your styles. For example, background : dark blue semicolon, color : white semicolon, text - align : center semicolon. That turns the hero section into a dark blue banner with centered white text. IDs are very powerful, but they come with a warning. If you later try to change the background with a class, like .hero-bg inside curly braces background : red semicolon, it won't work. The ID rule has higher specificity and wins over the class. That's why many developers avoid using IDs for styling. They keep IDs for navigation anchors or JavaScript hooks. There is a subtle difference between an ID selector and an attribute selector for the same ID. If you write h1 #headline, that is a type selector combined with an ID selector. If you write h1 inside square brackets ID equals double quote headline double quote, that is a type selector combined with an attribute selector. Both target the exact same element, but the ID version has more weight. We'll explore specificity properly in Chapter 4. For now, just remember they are not the same thing. A small curiosity, you can chain the same ID to itself like #logo. That doubles its specificity. It works, but it's almost never necessary. If you ever feel the need to write that, it's a sign your CSS has become too complicated. CSS is case sensitive. If you write .warning with a capital W, it will not match class equals double quote warning all lowercase. You must match the exact capitalization used in your HTML. This is a very common source of silent bugs. Always double-check your casing if a style doesn't apply. Class and ID names cannot start with a digit. If you have a class like 404 error, you cannot just write .404-error. You must escape the first digit. You do that with a backslash, then the numbers code, then a space. For the digit 4, the escape is \34 space. Then you continue with 04-error. So the full selector is \34 space 04-error inside curly braces color : red semicolon. This is rare, but good to know if you ever encounter auto-generated class names. Let's see everything working together across a small website. Imagine you have 3 pages: Home, About, and Contact. All 3 pages link to the same CSS file. In that file, you write type selectors for your base styles. H1 inside curly braces color : dark blue semicolon makes every H1 heading dark blue on every page. You write class selectors for reusable components. .btn inside curly braces background : blue semicolon color : white semicolon border : none semicolon styles every button with that class, no matter which page it's on. Highlight inside curly braces background : yellow semicolon adds a yellow highlight to any element with that class. And you use an ID selector for a banner that only appears on the home page. #home - banner inside curly braces background : light gray semicolon padding : 20 pixels semicolon only affects that one element. The About and Contact pages don't have an element with that ID, so the rule does nothing there. This is the power of mixing selectors. One style sheet keeps your design consistent, while each selector type plays its role. To sum up, use type selectors for broad, site-wide defaults. Use class selectors for reusable components and variants. Avoid IDs for styling. They create high specificity that makes overrides difficult. Use descriptive class names like .warning, not .red - text. Check your casing when styles don't work. Don't overqualify selectors. .card is enough, you rarely need div.card. Follow these simple rules, and your style sheets will stay clean and easy to maintain. Next, we'll learn how to group selectors and declarations so you can stop repeating yourself. Banner inside curly braces background : light gray semicolon padding : 20 pixels semicolon only affects that one element. The About and Contact pages don't have an element with that ID, so the rule does nothing there. This is the power of mixing selectors. One style sheet keeps your design consistent, while each selector type plays its role. Section 2.3 Grouping Rules. Grouping is one of the most useful habits you can build in CSS. Suppose you want H1, H2, and H3 to all have the same dark blue color. You could write 3 separate rules, one for each heading, but that means repeating the same color 3 times. If you ever need to change it, you have to change it in 3 places. Grouping lets you combine selectors so you only write the style once. Let's see how. To group selectors, you write a list of selectors separated by commas. The comma means "and also." So H1, H2, H3 means select H1 and also H2 and also H3. After the list, you put your normal curly braces and the declarations inside. For example, H1, H2, H3 inside curly braces color : dark blue semicolon. Now all 3 heading levels become dark blue. The browser treats each selector in the list as if it had its own rule, but you only wrote it once. This is much easier to read and maintain. Grouping isn't only for selectors. You can also group declarations inside a single rule. A declaration is a property and its value. Suppose you want your buttons to have a blue background, white text, and no border. You could write 3 separate rules for button, but it's far better to put all 3 declarations together in one rule. Write button inside curly braces background : blue, semicolon color, white, semicolon border : none, semicolon. That one rule gives every button all 3 styles. The semicolons separate each declaration, so the browser knows where one ends and the next begins. Always include the semicolon after each declaration, even the last one. This is good practice and prevents mistakes. You can group selectors and group declarations at the same time. Suppose you want H1, H2, and H3 to share not just the same color, but also the same background and padding. You write H1, H2, H3 inside curly braces. Then you put all the declarations inside those curly braces. Color : dark blue semicolon background : light gray semicolon padding : 10 pixels semicolon. Now all 3 heading levels get dark blue text, a light gray background, and 10 pixels of space inside. You only wrote one rule, but it does the work of 9 separate lines. This is how professional style sheets stay clean and small. There are 2 common mistakes to avoid. First, don't forget the comma. If you write H1 space H2 without a comma, that means something completely different. it selects an H2 that is inside an H1. That's a descendant selector, which we'll cover later. So always include the comma when you mean, and also. Second, only group properties that should truly be the same for every selector in the list. If you group font-size across H1, H2, and H3, they will all become the same size, and you'll lose the natural heading hierarchy. Instead, group only the shared properties, and then write separate rules for the unique ones. Grouping is simple but powerful. Group selectors with commas when you want the same styles on multiple elements. Group declarations inside a rule when you want to keep all the styling for one selector in one place. Combine both to write less code and make future changes easier. And remember, semicolons separate declarations, and only group properties that should be the same. Now you're ready for attribute selectors, a way to target elements based on their attributes, not just their name or class. Section 2.4. Attribute selectors, styling by metadata. So far, we've selected elements by tag name, class, and ID. But HTML elements can carry many other attributes. href on links, type on inputs, disabled, required, data-custom attributes, and more. Attribute selectors allow you to target elements based on the presence or value of any attribute. They're written inside square brackets. The simplest form is just the attribute name inside square brackets. Inside square brackets, disabled selects every element that has a disabled attribute, regardless of its value. This opens up styling possibilities that go far beyond classes alone. To match an exact attribute value, you write the attribute name and equal sign, and the value in quotes inside the square brackets. Inside square brackets, type equals double quote email double quote selects only input elements whose type attribute is exactly email. This is stricter than just checking for the attribute's presence. The value must match completely, even extra whitespace can break it. This exact matching is case-sensitive by default, meaning inside square brackets type equals double quote email double quote would not match an input with type equals double quote email double quote unless you use the case insensitivity flag, which we'll cover shortly. Attribute selectors also give you powerful partial matching operators. The == operator selects elements whose attribute value starts with a given string. For example, inside square brackets href double quote https double quote selects all secure links. The $= operator matches values that end with a given string, perfect for targeting file types, like links ending in .pdf. The * operator matches any value that contains the substring anywhere, useful for broad text matching. The == operator matches a complete word within a space-separated list, like one class among many. And the pipe = operator matches the start of a value followed by a hyphen, which is designed for language codes like N and N-US. Each operator solves a different real-world selection problem. By default, attribute value matching is case-sensitive. But you can make it case-insensitive by adding the letter I before the closing of the square brackets. So inside square brackets type equals double quote email double quote space I will match an input with type equals double quote email double quote, that is email in all lowercase. It will also match type equals double quote email double quote, that is email in all uppercase, or even type equals double quote email double quote, that is email with a capital E at the beginning. This is especially useful when working with attributes that might have inconsistent casing, like user-generated content or data from external APIs. The I flag works with exact matching and all partial operators, giving you flexibility when exact case isn't important. Attribute selectors encourage best practices. Instead of adding a class like external-link to every offsite link, you can simply use inside square brackets href double quote http double quote to style them automatically. You can highlight images that are missing alt text with img : not inside square brackets alt as a visual linting tool. Custom data attributes like data-theme or data-state can be used to control component variations without additional classes. The key benefit: your HTML stays semantic and meaningful, while your CSS derives styling from the existing metadata. It's a cleaner, more scalable approach. Attribute selectors transform your CSS into a metadata-aware engine. You can target elements not just by what they are, but by what they carry, their URL patterns, their accessibility attributes, their custom data. This is the bridge between semantic HTML and intelligent, self-maintaining style sheets. In the next section, we'll explore combinators, the symbols that let you navigate the DOM tree itself using parent-child and ancestor-descendant relationships. Section 2.5, the family tree parent, child, and descendant. We've selected elements by their tag, class, and attributes. But the real power of CSS comes from selecting elements based on their position in the DOM tree. This tree is a family. Elements have parents, children, siblings, ancestors, and descendants. CSS gives you combinators, symbols that let you express these relationships. The two most fundamental are the descendant combinator, which is simply a space between selectors, and the child combinator, which is the greater than sign. In this section, we'll master both so you can target elements not just by what they are, but by where they live. The descendant combinator is simply a space between two selectors. The pattern article space P means select every P element that is inside an article, no matter how deeply nested. The space says any descendant at any level. It doesn't matter if the paragraph is a direct child, wrapped in a div, or buried inside a section. As long as it's somewhere inside the article, it gets the styles. This is the most commonly used combinator because it matches the natural nesting of HTML. But because it reaches arbitrarily deep, it can also be too broad if you're not careful. Because the space combinator reaches all descendants, it's easy to accidentally style more than you intended. If you write nav space A, you'll target every link inside the navigation, including those inside submenus, footer links inside a nav tag, or any other nested element that happens to contain an anchor. The fix isn't to avoid the descendant combinator. It's to pair it with more specific selectors, usually a class on the immediate container, like nav.primaryLink, or to use the child combinator when you need to limit the depth. We'll see that next. The child combinator, written as a greater than sign, limits the selection to direct children only. Article greater than P means select P elements that are immediate children of article, nothing deeper. This gives you precise control over your component structure. If your markup places a paragraph directly inside the article, it will be styled. If that paragraph is wrapped in an extra div, the child combinator will not match it. This is stricter, more predictable, and often preferred for layout components where you control the exact nesting. The child combinator is perfect for building structured components. When you write .card greater than img, you are declaring, in this component, the image must be a direct child of the card container. This makes your CSS self-documenting. It tells your team exactly how the HTML should be structured, and if someone breaks that structure, the styles fail visibly, alerting them immediately. This is a huge improvement over loose descendant selectors that silently apply to unintended elements. Together, the descendant and child combinators give you a sliding scale of specificity. Space for broad, forgiving styles, greater than sign for strict component-level control. We've now navigated the DOM vertically, from ancestor to any descendant with a space, and from parent to direct child with the greater than sign. These are the foundation of layout and component styling. But the DOM is also horizontal. Elements can be siblings, sitting next to each other under the same parent. In the next section, we'll explore the adjacent sibling combinator, the plus sign, and the general sibling combinator, the tilde, to style elements based on their neighbors. Section 2.6, Siblings and Neighbors. We've traveled up and down the DOM tree with descendant and child combinators. Now we move sideways. Elements that share the same parent are siblings. CSS provides two combinators to target siblings: the adjacent sibling combinator, written as a plus sign, and the general sibling combinator, written as a tilde. These let you style an element based on the element that comes right before it, or any element that precedes it. This is incredibly useful for spacing, layout, and state-driven styling. The adjacent sibling combinator, written as a plus sign, selects the element that comes directly after a specified sibling. The pattern h2 plus p means find every h2, and if the very next sibling element is ap, style that p. The two elements must share the same parent, and the second element must be the immediate neighbor. No other element can come between them. This is perfect for removing unnecessary top margins on a paragraph that directly follows a heading, or for styling the first list item differently. The general sibling combinator, written as a tilde, is broader. H2 tilde P selects every P element that is a sibling of an H2 and comes after it in the document order. The elements don't have to be adjacent, they can be separated by other siblings. This is useful for applying styles to a whole group of elements that follow a particular breakpoint, like all paragraphs after a heading inside an article, or all list items after a certain marker. These combinators shine in real layouts. Imagine a navigation heading followed by a list of links. You want a border above the list, but only if the list immediately follows the heading. H3 plus UL does exactly that without adding a class like bordered. If you have multiple lists stacked together, UL plus UL adds a gap between them, but leaves the first list alone. This replaces many handcrafted spacing utilities with a single, elegant rule. It adapts automatically as your HTML changes. Remove a heading, and the border disappears. There's an important catch. Sibling combinators only look forward. You cannot write a selector that says style and H2 that is followed by AP, because CSS can't see into the future of the DOM. The element you want to style must come after the reference element in the source order. If you need to style something based on a later sibling, you either restructure your HTML so the dependent element comes later, or you use the has pseudoclass, which we'll cover in the next chapter. For now, remember, siblings are a forward-only relationship. You now know how to navigate the DOM tree in every direction. Down to descendants with a space, down one level to children with the greater than sign, and sideways to siblings with the plus and tilde. These four combinators form the complete spatial language of CSS selectors. In the next section, we'll meet the universal selector, the star that matches everything, and learn how to combine selectors into powerful lists with the is, and, where pseudoclasses. Section 2.7, the universal selector and selector lists. The universal selector is the broadest selector in CSS. Written as a single asterisk, it matches every element in the DOM. It's the nuclear option of selection, use it, and every box on the page gets the same styles. That makes it useful for global resets, like setting box sizing to border box, or for debugging layouts with an outline. But its breadth is also its danger. Styles applied to the universal selector affect everything, which can lead to unintended side effects. Let's explore when to use it, when to avoid it, and what modern CSS offers as smarter alternatives. The star selector is a tool, not a villain. It's perfect for resetting box sizing across the entire document. In fact, most modern resets start with star, comma, star colon colon before, comma, star colon colon after inside curly braces box dash sizing colon border dash box semicolon. You can use it to strip all margins and padding, or to visually debug complex layouts. However, avoid pairing it with properties that trigger layout or paint, like transition, on every element. Despite an old myth, the universal selector is not inherently slow. Browsers are highly optimized for it. The performance cost comes from what you apply, not the selector itself. Now, let's level up selector grouping with two modern pseudoclasses, :is and :where. The is function accepts a comma-separated list of selectors inside its parentheses and acts like a grouped selector list, but with a crucial twist. Its specificity is not the sum of its parts. It's the specificity of the most specific selector inside it. For example, is open parenthesis h1 comma dot headline close parenthesis has a specificity of 010, the same as a class, because dot headline is the most specific item in the list. This allows you to group selectors without worrying about the order, while still controlling how hard they hit in the cascade. The :where pseudoclass works exactly like :is, except for one enormous difference. Its specificity is always 0, no matter how specific the selectors inside it are. Even if you put an ID inside :where itself contributes nothing to the specificity score. This makes it perfect for defining base styles or framework defaults that you want developers to override easily, without fighting specificity wars. Use colon is when you want grouping with teeth. Use colon where when you want grouping with humility. Think of it this way, colon where is the gentle giant. It applies styles broadly but steps aside the moment something more specific arrives. That's ideal for reset styles, framework defaults, or any theme you expect to be customized. Colon is the assertive one. It groups selectors while preserving their combined power, which is useful for component states or conditions where the styles should stick. Both are huge improvements over raw comma-separated lists because they reduce repetition and manage specificity in a predictable, controllable way. We've covered the universal selector and the modern grouping power of colon is and colon where. The star is your global reset tool, efficient and safe when used correctly. Colon is lets you group selectors with the specificity of the strongest link. Colon where lets you group with zero specificity, making overrides effortless. In the next and final section of this chapter, we'll weave everything together. Type, class, attribute, combinators, and these new tools into a cohesive selector strategy that keeps your style sheet scalable and maintainable. Section 2.8. Putting it all together, selector strategy. We've spent this entire chapter learning every fundamental selector and combinator in CSS. You know how to target elements by tag, by class, by ID, by attribute, by their position in the DOM tree. But collecting tools is not enough. The difference between a CSS beginner and a CSS professional is not knowing more selectors. It's knowing when to use which one. In this final section, we'll build a selector strategy. A set of principles that keeps your style sheets clean, scalable, and easy to maintain. Consider this the blueprint for every selector you'll write from now on. The golden rule of selector strategy. Always use the lowest specificity that gets the job done. Start with type selectors for your global defaults, body text, heading sizes, link colors. These are your foundation. When you need to target a specific component, reach for a class. Classes are the sweet spot, reusable, explicit, and only moderately specific. Avoid IDs for styling unless there is genuinely no other way. They create specificity spikes that are hard to override. And never, ever use inline styles for static design. This creates a natural cascade. Global styles flow into component styles, and overrides are easy because nothing is fighting from an unnecessarily high specificity pedestal. Let's build a card component with a strategic approach. We start with a class.card to scope all styles for this component. We use child combinators, the greater than sign, between the card and its direct children. The image, the content wrapper, and inside the content wrapper, the heading and paragraph. This keeps the styles tightly scoped to the card's expected HTML structure. The button is styled with its own reusable class.btn, not tied to the card, so it can be used elsewhere. There are no IDs, no deeply nested descendant selectors. If we need a card with a different background, we can add a modifier class like .card-featured. The styles are easy to read, easy to override, and easy to delete when the component is retired. This is selector strategy in practice. The deepest pitfall in CSS is the specificity war. It starts innocently. You can't override a style, so you add a longer selector. That works, but now someone else needs to override your override, so they go even deeper. Before long, your style sheet is full of selectors like body hash main.content article section p, and the only way to change a color is to write something even longer or drop an important flag. This is a choice. You can avoid it by using flat, class-based selectors from the start. When every component is scoped to a single class, there's nothing to fight. Overrides are clean. Add a modifier class, or use a higher-level component wrapper. The cascade should flow, not battle. Here is your selector strategy checklist. Use type selectors for your global defaults. Scope every component with a single class as its root. Use additional modifier classes for variants, never deeper nesting. Use the child combinator sparingly to enforce structure inside components. Avoid IDs for styling. Use colon where for base framework styles that you want others to override easily. Use colon is when you need to group selectors while retaining their collective specificity. Turn to attribute selectors when the styling should be driven by semantic metadata. And never use inline styles for static design. If you follow these principles, your style sheets will remain clean, flexible, and maintainable, even as your project grows. Chapter 2 is complete. You now have a complete toolkit of selectors and, more importantly, a strategy for using them wisely. You can target any element in the DOM with precision, and you know how to keep your style sheets from spiraling into chaos. In the next chapter, we'll expand your targeting power even further with pseudo-classes and pseudo-elements. Selectors that respond to element states like hover and focus, and let you style parts of the DOM that don't even exist in your HTML. The journey continues.